Some important MCQs. A scale measures the mass of an apple as constantly as 0.5 kg less than the actual mass. The options are accurate and precise, accurate and non-precise, precise but not accurate. Which one is right? Well, the C option is 100% right. 0.5 is precise because the scale is constantly measuring 0.5 kg, 0.5 kg and 0.5 kg. But this result is not accurate because it is less than the actual mass. The mass of a bag is 10.5 kg. A student measured it as 12.5 kg, 10.6 kg, 9.5 kg. The options are precise but not accurate, accurate and precise, accurate and not precise. Can you guess the correct option? Well, the correct option is C. It is accurate because one measurement of the student is matching the actual measurement. On the other hand, it is not precise because 9.5 kg is way different from 10.6 kg. Thus, this is all about accuracy and precision. Remember that we will not discuss topics of 9th class which we have already learned, like atomic masses, relative atomic masses, atomic mass unit, percentage composition, etc. So the next important topic is dimensional analysis. The process of converting one set of units to another is called dimensional analysis. For example, convert 3045 meter to kilometer and 35 degrees centigrade to Kelvin. We know that in 1 kilometer there are 1000 meter. So I divide 3045 meter by 1000. I get 3.45 kilometer. On the other hand, in 1 degree centigrade there are 273 Kelvin. So 35 plus 273 is equal to 308 Kelvin. Thus this process of converting units from one set to another is called dimensional analysis. The ninth topic is laws of chemical combination. Well, there are 5 different laws or 5 subtopics that describe the basic rules by which atoms and molecules combine together. The first law is law of conservation of mass. Remember that it is all about the mass. It states that mass can neither be created nor destroyed in a chemical reaction. For example, consider 2 grams of hydrogen and 16 grams of oxygen. When they both react together, they form water. Now if we measure the mass of the water, it would also be 18 grams. So we say that the mass of the reactants is 18 grams and the mass of the product is also 18 grams. Thus they both are equal. That's why we say that mass can neither be created nor destroyed in any chemical reaction. The second law is law of definite proportion. Remember that it is based on ratio of masses. The word definite proportion means fixed amount. It states that chemical substances are made up of elements that are present in fixed ratio by mass. For example, consider water and hydrogen peroxide. In water, the ratio of hydrogen to oxygen is 2:1, while in hydrogen peroxide, the ratio of hydrogen to oxygen is 1:1. It shows that the ratio of oxygen and hydrogen would always be 2:1 in the water, while the ratio of hydrogen and oxygen in hydrogen peroxide would always be 1:1. Therefore, we say that chemical substances combine in fixed ratio by mass. The third law is law of multiple proportion. It is very difficult for students, but I will crack it. It is also based on ratio of mass. Now consider 2 elements like X and Y. Let they form 3 different compounds. XY, XY2, XY3. Now we can see that the ratio of X in all these 3 compounds is 1, while the ratio of Y in all these 3 compounds is 1, 2 and 3. Now listen carefully. We say that if Y combine with the same element X, the ratio of Y is whole number like 1, 2, 3. Let me repeat it. If Y combine with the same element X, the ratio of Y is the whole number like 1, 2, 3. This is what the law of multiple proportion explains. Let me give you one real example. Consider carbon monoxide and carbon dioxide. In carbon monoxide, the ratio of masses is 12:16, while in carbon dioxide, the ratio of masses are 12:32. Now dividing this whole thing by 12, in carbon monoxide, the ratio of carbon is 1:1.3, while in carbon dioxide, the ratio of carbon is 1:2. So the ratio of carbon is 1 in both the compounds, but the ratio of oxygen is 1:2, which is again whole number. Therefore, this law states that when 2 elements like X and Y form 2 different compounds, the ratio of the mass of Y can be expressed as whole numbers. So this is what the law of multiple proportion teaches. The fourth law is Gay-Lussac's law. Remember that It is based on volume of gases. It states that pressure is directly proportional to temperature. For example, consider oxygen gas in this cylinder. If we increase the temperature of the gas, the rate of collision of oxygen molecules on the wall of container is increased. As a result of this, pressure is increased. So we say that pressure is directly proportional to temperature. The fifth law is Avogadro's law. Remember that this law is based on volume and mass of a gas. It states that volume is directly proportional to number of moles or mass of the gas at constant temperature and pressure. For example, consider these balloons. As you fill these balloons with more air or more mass, their volume increases. Remember that we can also write Avogadro's law as equal volumes of any two gases at constant temperature and pressure contains the same number of moles or same masses. For example, consider 2 cube hydrogen gas and 2 cube of oxygen gas, that they both are present at constant temperature and pressure. So we say that they both contain equal number of molecules. Thus noted down these laws of chemical combinations. The 10th topic is mole and Avogadro's number. In our daily life, we say that 1 dozen egg is equal to 12. So we say that 1 dozen is nothing but just like a number. Now to learn the concept of mole and Avogadro's number, we should learn relative atomic mass and molar mass. For example, the relative atomic mass of carbon is 12 AMU. Remember that there is only one atom of carbon present. Now we cannot touch, we cannot see, and we cannot do chemistry with one atom of carbon. To solve this issue, scientists put forward the idea of molar mass. Now instead of 12 AMU, if I take 12 grams of carbon, it is known as a molar mass. Remember that we can touch, we can see, we can do chemistry with molar mass of carbon. We know that in 12 AMU, there is only one atom of carbon, but in 12 grams, there are total 6.023 into 10 to the power 23 atoms. Thus this number is known as Avogadro's number. Thus remember that in 12 grams of carbon, there are 6.023 into 10 to the power 23 atoms. Now listen carefully. 1 mole is always equal to molar mass of an atom, molecule or formula unit. Also we know that molar mass of any atom like carbon, molar mass of any molecule and molar mass of any formula unit contains 6.023 into 10 to the power 23 atoms. So remember that 1 dozen of anything is always equal to 12. 1 mole or molar mass of any atom, molecule or formula unit contains 6.023 into 10 to the power 23 particles. If you want to learn more about mole concept and Avogadro's number, we have already uploaded a very dedicated video and its link is given in the description. The last topic is molarity and molality. Now molarity is the number of moles of solute dissolved in 1 liter solution. Remember that we do not consider solvent and molarity. For example, consider some water in this object. I add 2 mole sugar to this water. After adding 2 mole sugar to this water, the volumes of solution becomes 1 liter. So we say that the solute is sugar and we have dissolved 2 moles of it. The solvent is water, the volume of solution is 1 liter. So the molarity of this solution is 2m because we have dissolved 2 moles of sugar in 1 liter. Remember that the formula of molarity is number of moles of solute upon volume of solution. On the other hand, molality is the number of moles of solute dissolved in 1 kg of solvent. Remember that we do consider solvent in case of molality. For example, firstly, I take 1 kg of water in this object. Now let's consider that I add 4 mole of sugar to this 1 kg of water. Now we know that the solute is sugar and we have dissolved 4 moles of it. The solvent is water and the mass of the solvent is 1 kg. So the molality of this solution is 4m because we have dissolved 4 moles of sugar in 1 kg of solvent. Remember that molality is denoted by small m and it is equal to number of solute upon mass of the solvent in kg. I hope that you have learned the important concepts of first chapter of chemistry.